Question 3.1. Given tan 24 is equals to k, determine the following in terms of k. Given that the tangent of 24 is equal to k, determine the following in terms of k. So we are dealing with question 3, specifically 3.1. 3.1, which is what we are dealing with. And specifically, we are going to deal with 3.1.1. What do we need to determine in terms of k? We need to determine such that cos 24, the cosine of 24, we have to determine it in terms of k. So we must have cos 24 is equals to blah, 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 blah in terms of k. Understanding that the tangent of 24 degrees is equal to k. Remember, the tangent is opposite over adjacent. So the tangent of 24 can be written as actually a fraction. It's actually a k over 1. Opposite over adjacent. Because this stands for the opposite side and this stands for the adjacent side. Because tan is opposite over adjacent. Also referred as y over x. The tangent of 24, the tan of theta is y over x. The tan of 32 is y over x. No matter the angle here, the tan of 24 is always measured as opposite over adjacent. Which means this k stands for the opposite. You can write this in pencil. And the 1 is actually for adjacent side. The 1 is actually for the adjacent side. Or the y over x, if you want. Is the y over x. We can use the y over x because it's not going to be ambiguous in this instant, as we already have k. That becomes, of course, from Pythagoras, you will remember that there's hypotenuse squared is equals to adjacent squared plus opposite squared. Do you remember that? Meaning we have hyp squared is equals to k is adjacent, opposite over adjacent, which is 1 squared plus k squared, because the 1 is the adjacent side and the k, of course, is the other side. That would then give us such that the hypotenuse squared is therefore equal to just 1 plus k or k plus 1. I mean 1 plus k squared or k squared plus 1. However you want to write it, it doesn't matter. Telling you that the hypotenuse is in fact the square root of 1 plus k squared. Okay. Or k squared plus root k squared plus 1. So is square root of 1 plus k squared, or the square root of k squared plus 1. And please remember that the square root of 1 plus k squared is not equals to 1 plus k. Never. Instead, the square root of 1 plus k all squared is, in fact, 1 plus k. You have to be careful about these things. You have to be careful about these things because this is a perfect square. Hence, it's a perfect square. It can be square rooted. Since hypotenuse is that, what are you looking for? Are you looking for that? Nope. You are looking for the cos of 24. You are looking for the cosine of 24. Therefore, the cosine of 24, me and you know that the cosine is what? It is adjacent over hypotenuse. What is the adjacent side? That is 1 over the hypotenuse. 1 over square root of 1 plus k squared. Of course, you don't have to rationalize that for this question. This question does not necessarily require you to rationalize that, but you have the cos. You can rationalize it, of course, by multiplying both sides by that denominator. You can do that, and that will be also very beautiful. Thank you so much. Let's look into 3.1.2, which required us to find the sine of 156, also for 3 marks. The sine of 156. The sine of 156, that's how you're going to write it first. The sine of 156, you'll realize that this one would need a certain scale because 56 requires something different because 56, you'll realize, is 180 minus 24. Do you realize that? That sine of 156 is actually 180 minus 24. That's the sine of 56. It's 180 minus 24. And that, if you look at it, it now tells you about reduction formula. How is the sine in that particular quadrant, this ratio sine in that particular 180 minus in that particular quadrant is what? The second quadrant. Second quadrant, sine is positive. Sine is positive because remember, all students take coffee. So in that particular quadrant, sine becomes positive. That would then give you the sine of course, you're going to reduce to that angle. The sine, it's a positive sine, positive sine 24. Sine, what we know, it is opposite over hypotenuse. What is the opposite side? It is k. So that's going to be k over root 1 plus k squared, which is the hypotenuse side. And there you have the sine 156 solved. There you have the sine 156 solved. Then, up next, you have the cos 3.1.3. You have the cos 54. Cos 54, you realize, can I make this in terms of 24? In terms of a reduction formula? No. But I realized that 54 can be written as 30 plus 24, which takes you to a compound angle. And that particular compound angle, we know if it's positive, it's going to be cos 30, it's cos 30, cos 24, negative, sine 30, sine 24. So when it's positive, it becomes negative. Remember that? If it was negative for the cos, it becomes positive. And there we are. That would then lead us to the following. You know what is the cos of 30? You need to get used to the cos of 30. If we have to go to our calculator to remind you, because cos 30, you realize is a special angle. If we remind you of the cos of 30, it goes that the cos of 30 becomes root 3 over 2. So if cos 30 is root 3 over 2, the sine of 30 is going to be 1 over 2. So it's root 3 over 2. Cos 24, we already know what is the cos 24. Cos 24 is 1 over root 1 plus a k squared minus what's the sine 30 is 1 over 2. It's multiplied by the sine 24. Remember, how did we get sine 24? From there. It's k over that. It's k over root 1 plus k squared, which would then be when you rather simplify this further using general algebra, that is root 3 over 2 root 1 plus k squared minus a k over, 2 root 1 plus k squared. And that would give, I'm not going to rationalize this because for the context of this particular question, we don't necessarily need to rationalize. But of course, in the question, in the exam, it can be asked sometimes to say, rationalize your final answer. Rationalize the denominator on the final answer, and then you can actually do that. But that, I'm telling you, it's going to be root 3 minus k all divided by 2 root 1 plus k all squared. And that is your final answer. We're able to answer all the 3 questions at 3.1, cos 24, sin 24, and 150. Cos 24, sin 156, and of course, cos 54 degrees. And that is that. Keep on keeping on.